Okay, today we're going to talk about 10.4, inscribed angles, and polygons.
Can I do
Okay.
10.3 after school today? No.
Maybe. I probably won't get to it until later. So, inscribed angles and polygons. This is page 295 of your student journal. Alright. So if we're going, once again, you can go through and define these later to help you review, but if you take a look at the bottom, page 295, you have a couple of core concepts there. One's a theorem, but a few vocabulary terms. I want you to read through that. I want you to read the theorem there. Make some notes to yourself if you need to there. And then you can go on to the next page, 296, and read those theorems as well. I'm going to pause there for a minute. I'll let you finish reading the other page in a minute. But 10.10, well, first an inscribed angle. An inscribed angle touches... has three parts that touch your circle. It has a vertex on the inside of the circle there. Okay. The intercepted arc is the arc formed by the legs of that angle, and then the arc is said to be subtend the angle. So you're going to see that terminology here. You say AC subtends angle B, and that just means that this angle creates that arc. Okay. The measure of an inscribed angle is half the measure of the intercepted arc. So our formula to find this angle measure right here is to find your arc measure and cut it in half. Now please note the difference between that and when you have a central angle, and they're identical. Okay, so you're going to have a bunch of different things that that build off of what we've already learned. Okay, and we'll come back to that formula here in a minute, but when you look at the next page, few other theorems and core concepts. So I want you to go ahead and read through those quick. Okay, now some of these will really make sense, and some of them are, well, I think they all kind of make sense if we think through them, but if I have this angle, so let me trace these out here. If I have angle D, and then I have angle C, they are congruent. Okay? Why are they congruent? Tell your neighbor there. Okay. But if they intercept the same arc, then they have to be congruent angles because you're applying the same formula to each of them to find that angle. Right? So as long as they intercept the same arc. Now if I have an inscribed polygon, for instance a triangle in here. Well, first, an inscribed polygon means a polygon formed from all vertices lying on the circle. Okay, it's a circumscribed circle where you have an inscribed polygon there. Okay, if I have an inscribed polygon and I have a 90-degree angle here, then that means this length right here, AC, must be a diameter. Tell your neighbor, how come that has to be a diameter? Based on what we've been studying today, how do we know that if this angle is 90, then that hypotenuse must be a diameter? Why is that? Okay, how come? What does a diameter make when you have a diameter of a circle? What type of arc? Semicircle. What's the arc then? 180. How come we have to have a diameter if this is 90? Ian? Yeah, 90 is half of 180, right? So if you apply this formula, this angle is 1/2 of the intercepted arc. Well, if this is 90, then this arc would have to be 180. Okay? If this is 90, that arc that's intercepted has to be 180, meaning that side has to be a diameter. Okay? The next one, a quadrilateral can be inscribed in a circle if and only if its opposite angles are supplementary. That means this and this, if supplementary, add up to what? 180. So D plus F have to add up to 180. And G plus E have to add up to 180. How come? Talk about it. How come that has to be? Using the same ideas that we've been studying. Okay, for those of you struggling figuring out why, try to do try to draw a line going through those. Okay? Or at least intersecting the circle of opposite angle. What arc is created from angle D? Now, what arc is created from angle D? So, for instance, FG subtends angle G. So this angle right here slices out that arc. Correct? Okay. And its opposite angle, angle F, slices out that arc. How come those two angles have to be supplementary? Yeah?
So if complementary is for 90 and supplementary is for 180, what do you say when you say something?
Okay, that has nothing to do with the question. Okay, how come those two angles have to be supplementary? Yeah.
Because if they're not supplementary, then all the whole perimeter of the circle will be filled.
Okay, the whole perimeter of the circle, or the circumference of the circle, is filled. What is the circumference of a circle? Or how many degrees in a circle? That's not the circumference, but it's 360 degrees. And what do we know about these angles? They're inscribed, so they have to be combined. If I combine this angle and that angle, angle F, plus measure of angle G, divided by 2, well, those two angles together, the arc that subtends those angles would have to equal 360 total. Okay, if I want to find out the measure of the angle, I'd have to take that and divide it by 2. Okay, that would be 180 degrees. Okay, so as Alex said there, our whole perimeter, or the circumference of the circle, has been outlined here. Therefore, I'm taking 360 and dividing it by 2, which is 180. And no matter what, if you have a inscribed quadrilateral, the whole outer edge of the circle is going to be covered. So right now, I want you to draw a circle here. I want you to put 4 points on the circle, any 4 points. Okay, if you haven't put them on there yet, you're thinking about it way too much. Okay, and now I want you to draw a quadrilateral using those 4 points. What if you can't? It's 4 points. Okay, now I want you to trace out 2 angles that are opposite of each other. So when I say trace out, I mean like this. Okay, there's one angle. Here's the other angle. Is there any way of drawing a quadrilateral that would not take up the entire circle? Has anyone figured out how to do that if the angles are on the circle? Notice if you were to take different colors and trace them, you would take up the entire circle each time. Meaning this arc plus this arc equals 360. So half of that arc plus half of that arc would have to equal 180. Okay, that's what's happening there. So you're applying the formula we talked about at the beginning. Anyone draw a perfect circle here? When I try to draw, I'm not good at it. This one was pretty good. I always put a dot, and then as I draw my circle, I stare at that dot. So it's okay. Like if you want to practice drawing circles, so you're bored in class, not that you ever get bored in math, you just put a dot. Okay. But you know, if you're in another class, that gets boring. Okay. Very good.
That was a pretty perfect circle.
You get a pretty good one? That is pretty good. All right, everyone, 297. Give it a go. 1 through 5. Work with your partner. Yes. Angle A. intersects the semicircle, therefore half of 180 is 90. Angle C, well, if this is 90, and that's 28, 90 and 28, okay, well, 28 and this has to equal 90, so you can make your 180-degree triangle. So 90 minus 28 is, Maddie? Yes, 62, well done. Yeah, 62, good. All right, and Drew, BC, what did you get for BC? 14.4. So B, C. How did you get 14.4 for that? Just curious. You use SOHCAHTOA? Oh. SOHCAHTOA. So. Wow. That's some good singing there.
I didn't even know that was a laugh. I thought she was dying.
I think it was a good laugh. All right, so 3.9 squared. How about we use Pythagorean theorem? Okay. Either way, I think we'll get a bit of a different answer there.
Oh, that's BC. Oh, that's not numbers.
Okay.
BC. I thought this was BC for weird reason.
They're gonna guess.
8.3 on that one.
Yeah, me too. I think Carlo and Carlo.
I know, third period's great. Okay. AC. You figure out what happened? I'll have to come back and overlook. Yeah, what'd you get?
56.
56, how'd you get that?
I multiply 28 times 2 because the measure of the inscribed angle is half the angle. That is 56.
Good. All right, arc AB. Arc AB. If this is 56, this whole thing is how much? 180. 180 minus 56 is 124. Okay. You could have. Okay. Two pairs of congruent angles. Go ahead and tell your neighbor what you got. Two pairs of congruent angles. Okay, so we're looking for angles that have the same arc, like angle B and angle C. Okay, they both intersect arc AD. Okay. Another set of angles that intercept the same arc, angle A and angle D. All right, questions?
What about number 7?
Number 7, go ahead and figure out number 7, please. While you're doing number 7, I'm going to be handing out the first part of our assignment. Letter N is 180 minus 100. Opposite angles have to form 180, so it is 80.
Oh, the answer.
And letter M is 180 minus 65. Opposite angles are supplementary. It's 115. Okay, questions?